Draw the reinforcement details of a simply supported one-way slab with the following specifications and prepare the bar bending schedule. Specifications: number 1, spans. Clear span in shorter direction is equal to 3 meters. Clear span in longer direction is equal to 7 meters. Bearing on all the sides is equal to 300 mm. Overall depth of the slab is equal to 120 mm. Number 2, materials. Grade of concrete is M20. Grade of steel is equal to Fe415. Number 3, reinforcement. Main reinforcement 10 mm dia at 120 mm center to center. All the main bars are cranked on one side alternatively at a distance of 300 mm from the face of the support. Distribution reinforcement 8 mm diameter bars at 150 mm center to center. Hanger bars 3 numbers 8 mm dia on either side. Number 4, covers. Top cover, bottom cover and side covers 25 mm. Draw the following to a suitable scale. Number 1, bottom plan of the reinforcement. Number 2, cross section along the longer span. Number 3, cross section along the shorter span. First, prepare the schedule of reinforcement with the given details. Let's draw the slab figure. See, this is the shorter span, 3 meters. And this is the longer span, 7 meters. The main reinforcement is provided in the shorter span to resist the bending moment. See, it is the shorter span. The main bar is a cranked one on one side. So this is the cranked portion of a main bar. These cranked bars are provided like this. The crank portion is one side of the bar. One bar is placed like this and another bar is placed like this. Crank on this side and next bar is having a crank like this. So next bar is, see, this type of arrangement is made in this beam. So this is a cranked bar. Next bar is having a cranked portion here. So on this side, say it is another crank, another bar. In the cross section, this looks like this, and which is a distribution bar. This is another cranked bar. See, based on the calculation, we can provide the n number of distribution bars, and in the question, they have given the 3 hanger bars on either side. So these are the hanger bars. Now find out the length of the main cranked bar. Say it is A, main cranked bar. See, the diameter of main cranked bar is 10 mm and it is cranked on one side. Calculate the length of main cranked bar. The length of main cranked bar, LMC, is equal to, so length of main cranked bar is provided in the shorter span. So clear span in shorter direction is equal to 3000 mm plus 2 into bearing on either side is 300 mm minus end cover. So 25 mm on either side. So 2 into 25 mm plus one crank allowance. One crank allowance. So we have calculated this crank allowance in the beam problem. So length of main cranked bar is equal to 3000 plus 600 minus 50 plus 0.414 into, this is the slab. Overall depth of slab is 120. This central portion vertical distance is D. Center of this reinforcement here to here. Overall depth 120 minus top cover minus bottom cover, which is 2 into 25 minus dia by 2 minus diameter of crank bar by 2. 10 by 2 on top side minus 10 by 2 on bottom side. Length of main crank bar is equal to 3574.84 mm. So this can be written as 3575 mm. Calculate the number of main cranked bars. It is Nm. Main cranked bars are provided in the short span direction. To get the number of this main cranked bars, we need this length, excluding the end covers. Therefore, number of main cranked bars is equal to total length of the slab in longer direction, excluding the end covers, divided by center to center spacing of main cranked bars plus 1. $7,000 plus 2 times the bearing minus 2 into 25 end covers, divided by spacing is 120 mm plus 1. Therefore, number of main cranked bars is 63.916, which is equal to 64. Let's calculate the distribution bar length. Designation is B and diameter of distribution bar is 8 mm. Length of distribution bar LD is equal to, so which is equal to the length of the slab in longer direction excluding the end covers. So clear span in the longer direction is 7,000 plus bearing is 300 on either side. So take 2 value and deduct end covers 25 mm on either side. Therefore, LD is equal to 7550 mm. See, the distribution bars are provided in longer span. So the number of distribution bars will be find out using this span. ND, number of distribution bars, is equal to total length of slab in shorter direction excluding end covers divided by center to center spacing of distribution bars plus 1. So in the shorter direction, clear span is 3 meters in mm, 3000 mm, plus bearings on either end 2 into 300 and deducting the end covers 2 into 25 divided by center to center spacing is 150 mm plus 1. Number of distribution bars is 24.667, round it to 25 and find the length of hanger bars. Say C hanger bars. Length of hanger bar is equal to LH. These bars are placed in the longer direction. So clear span in the longer direction plus 2 into 300 bearing minus 2 into 25 end cover. Therefore LH is equal to 7550 mm. Now prepare the bar bending schedule from the length of different bars. So first one is main cranked bar. The designation is A and the shape of the bar is, say, I'm writing the designation here. Shape of the bar is this one. And diameter of bar is 10 mm. So diameter in mm, number of bars in numbers, length of bar in meters, total length is in meters, weight is in kg per meter, total weight is in kgs. So for the main cranked bar, number of bars calculated are 64, length of the bar is 3.575, total length is equal to number of bars into length of the bar, 228.80 meters, weight is equal to diameter square by 162.2. Here diameter is equal to 10. Therefore weight of the bar is equal to 0.616. Total weight is equal to total length of the bar into weight of the bar. 6th column into 7th column. Total weight is equal to 140.940 meters. Number 2. Next bar is distribution bar, which is having a shape of straight one. The designation is B. Diameter of the distribution bar is 8. Number of bars 27. Length of the bar is 7.550. Total length 3.850. And weight of the bar is 8 square by 162.2, 0.394. Total weight is equal to this one into this one, 80.316 meters. Third one, hanger bar, designation is C. Diameter of hanger bar is 8. And number of bars are 6. 3 on one side and 3 on another side. 3 plus 3 is equal to 6. Length of bar 7.550 and total length is equal to 45.300. Weight of the bar is 8 square by 162.2, 0.394. Total weight is equal to 17.848 meters. Therefore, total quantity of steel is equal to 239.104 kgs.